Okay.
Perfect. So 1 minute and we'll get started. Thank you everyone for joining the March 2021 VMware TAM customer webinar. This webinar is organized by the VMware TAM organization in order to provide our customers the opportunity to hear great content and to interact with our great speakers that are delivering it. The goal of this is to make sure you're getting the full benefit from your software. Please make use of the Q&A feature to ask any questions. And if your question doesn't get addressed today, please be sure to reach out to your TAM and ask them to follow up. Before we get into today's content, there are just a couple of basic announcements. Our next TAM VMware customer webinar will be on the 15th of April, and we will have the privilege of being joined by Tobias Lilly, one of our cloud management technologists, to talk about the role of automation in your digital transformation. As I mentioned earlier, we want you to get the full benefit from these services by interacting with the speaker. So if you have any questions during today's webinar, please use the Q&A feature of Zoom and we'll address them during or at the end of the webinar. At the end of the session, you'll be prompted to fill out a simple 2-question survey related to the value you received from this session on any topic suggestions for future sessions. Your completion of this survey is a very valuable gift back to us, and we'd really appreciate it. And lastly, this webinar is being recorded, as I'm sure you've already seen, and your TAM can make this recording link available to you whenever you'd like. So a few months after this, the recording will then be publicly available on the VMware TAM Services YouTube channel. So this brings us to today's speaker and topic. This is Dimitri Desmet, who's a Senior Product Manager in the NSBU, and he will be talking to us about NSX-T Multisite versus Federation. Dimitri, please go ahead.
Okay. So that's maybe something you've already seen because I talked about multi-site in 2019 VMworld. I talked about Federation in 2020 VMworld. This session is a new content, so you should learn hopefully a little bit more. There is some repeat to explain the basics, but then you will go deeper. And as said, feel free to open questions, and I will reply to them on the fly to make it as interactive as possible, even if you're not able to ask the question with the microphone. Okay. Before starting, I just want to highlight, if you're not aware of it, there is a specific design guide on multi-location. So this one is talking about our 2 solutions to offer logical network and security services in a multi-site environment, with the solution NSX Multi-Site and with the solution NSX Federation. So both are covered here. With an introduction that explains the sweet spot for each of those 2 solutions. This deck is mainly based on that. So what is this deck? I'll start with the positioning, the sweet spot for each of the 2 solutions. And then, since multi-site has been here for a very long time, I'll just follow up specifically on Federation. That said, if you have questions on multi-site, feel free to ask. There is a lot of content. Hopefully, we have 1 hour and 30 minutes. Hopefully, I'll be able to go to the end of it. But if not, anyway, you'll have the deck, and you can always reach to me. And also, again, this content is available in the design guide. So, positioning. Very quick, because I'm sure you know already this. I mean, each data center has needs in terms of network, switching, routing, NAT, load balancing, and so on and so forth, DHCP, DNS, and also security. You've heard about the micro-segmentation or internal firewall, whatever fancy name, or intrinsic firewall, whatever fancy name marketing comes up with every 2 years or every 1 year, new name. But at the end of the day, yeah, they have network and security needs. And since we're talking about NSX and a lot of those services are offered in a distributed fashion, I added those two icons. But yes, that's how distributed routing, distributed firewalling, they have those needs. And when you have multiple data centers, you have a need for all of them. So we have two solutions. The first one is NSX Multi-Site on the left. The second one is NSX Federation. The idea is, yes, to offer a central point of configuration for those services. In the solution NSX-T Multisite, there is a single NSX-T manager, the one you know since for a few years. So it's an single NSX manager, and this one is controlling hosts, transport nodes, so ESX, edge nodes, that are physically in multiple locations. But yeah, actually, technically speaking, NSX, the manager is not aware they are in different locations. It's just you make a configuration. So you can have those services in all the locations, but have specific north-south going out via one way or another way and DR, but it's just based on configuration. Where this one, there is a new element with NSX-T Federation, which is a global manager. So it's a new element. And this one gives you, again, the same thing, central configuration, central management, central operation of all your services, network and security. And that central configuration is pushed to local NSX managers. So we call them LM, but LM is the NSX manager, and it's the same as this one. It's just the NSX manager offering locally network and security services to their local site, but they are centrally configured by a central element, which is the global manager. So both solutions are available today, and they will remain available in the long run, because there is a sweet spot for each of those two solutions. The first one, NSX Multi-Site, the sweet spot is really when you have a limited number of locations, so usually 2 locations. So 2 locations only. It does not mean it does not work with more than 2, but then the configuration is a little bit more complex. So the sweet spot is 2 locations and close by. Why? You'll see that in the VMworld session I did in 2019, that makes the fact that they are close by, that makes the DR solution much easier. Does not mean, again, you cannot do multi-site with long distance, but as you will see, it's in the VMworld session, that's the configuration and the steps to recover are more complex. So long story short, multi-site, sweet spot, 2 locations, close by. NSX Federation, all the other use cases. That's the high level positioning. Now the detailed positioning,
We've just got a question. So are there any latency requirements in the federation setup?
Yeah, we'll talk. That's a good question. And I have a section at the end on requirements. So yes, there is a requirement in terms of latency between the GM and LMs, between the GM and LMs, between the GM and LMs, and between the LMs and LMs. It's 150 milliseconds today. So you cannot do the world, but we are working on making it 500 milliseconds. So then you'll do the world. But today, yes, it's 150 milliseconds. That's what we tested in QA. So back to multi-site. Multi-site, there is also actually a requirement in terms of latency. Even if the sweet spot is 10 milliseconds latency, it can work above that, up to 150 milliseconds as well. And so the pros of the multi-site is a very small footprint, because for all your locations, you just have 1 manager cluster, so 3 VMs, and that's it. Simple DR solution to recover in case of failure of location 1, to recover all the network and security services in location 2. So a simple DR, as long as you have small, low latency, 10 milliseconds latency between location A and location B, and some requirements on the fabric, which are a stretched VLAN, physically stretched VLAN, and vSphere HA in your cluster. So I don't want to go too deep. It's again detailed in the VMworld session and in the design guide. But at a high level, yeah, the pros are small footprint, as you can see, simple DR if you fit the requirements on the fabric and the vCenter, and low latency. And almost all the network and security features available on NSX are available there. The one that are missing are the service insertion, if you want to redirect to a Palo Alto, a checkpoint, or things like that. The cons, or everything else is available. The cons is, yeah, you're limited in terms of scale. One NSX manager can manage X number of ESX, today it's 1,000. And if you want more than 1,000, not in one location, but in all your locations, then you cannot go with this solution. So 1,000 is a lot, but for very large customer, that's a limit that prevents them to go with multi-site, with the NSX-T multi-site solution. You need large MTU across locations, because an ESX in location A needs to be able to talk to an ESX in location B, and using the Genève protocol encapsulated traffic. So we require a large MTU, as you know, for the Genève traffic between ESX and ESX. So that means you need large MTU across your locations. And you have a single management plane that is physically in one location. So if you lose that location, you lost your management plane. So you cannot do any config change, you cannot do any vMotion, you cannot create new VMs, as long as you recover the NSX manager into location B. It can be completely automated with simple DR, with some requirements again, stretch VLAN management and vSphere. So it's fully automated, but it takes 10-ish, 10, 12 minutes. And during those 10, 12 minutes, when you lose location 1 and manager is not automatically recovered in location 2, you have no control plane. You cannot spin up new VMs, you cannot change a network, cannot change security. Yeah. Okay, so that's it for the management plane sweet spot and pros and cons. I see there are questions. There are independent vSphere clusters, not stretch clusters. Does each site has its own vCenter? Yes. With NSX Multi-Site, you can have a vCenter 1 in location A in location A, a vCenter B in location B. That's completely fine. They don't have to be stretched. For the simple DR, you need vSphere HA. For the automatic simple DR, you need vSphere HA, which means you need a stretch cluster. For the management, where you have your NSX manager VMs. Not for the VM production, they don't have to be stretched, the vCenter. However, if you don't care about automatic recovery of the management plane, in case you lose location A, where you have your NSX managers in location A, you can use also SRM. But as you know, SRM, you still need click, click, click. It's not automatic recovery. And if you don't mind, in the unlikely case of losing location A, and you're okay with recovering the management plane with SRM with some click, then that's just fine. And here you don't need any stretch vCenter. Wow, plenty of questions. I don't know if I'll have time to go through all of them, because we have a lot of content. Let me start, and then I may reply to all questions at the end. In multi-site, can we distribute NSX-T managers across sites? Yes. In multi-site, you could have an NSX manager in location A, one of the 3 VMs in location A, one of the 3 VMs in location B, and same location C, or 2 here and 1 here. It's detailed in the design guide. So that's cool. The only requirement is low latency. They have to be within 10 milliseconds. So if you can do that, yeah, that's perfectly fine as well. Are you permitting to stretch manager? Yeah, we talked about that. Sorry, regarding MTU, what OS do we recommend? What OS the recommended? What is the recommended side? The same as always. So we recommend 1700. It can be bigger, but we recommend 1700. NSX-T managers. So yeah, I replied on that. Last one, NSX-T manager. Can you stretch across the 3 sites? One, but yeah, you can also. I replied that. Okay, done that. All questions. Oops. Now let's talk about. Sorry. Come on. Here we go. Now the detailed positioning of federation. So we talked about the detailed positioning of multi-site before. So here, there is a local management plane in each location. So if you lose one location, let's say location A, and it happened to be the global manager active is physically in location A, you lost your central point of configuration. You lost also everything in location A, but you still have location B, LMB, you still have LMC, so you can still do vMotion, you can still do DRS, you can still create new VMs in location B, waiting for the global manager to be active on the standby. You can still do configuration if you want urgent configuration directly on LM. So yeah, you have local management plane, that's a plus for some customers. You do not need large MTU across locations. We'll talk about that later. For the communication from a VM in location A to a VM in location B, whatever on the same subnet L2 or different subnets L3, there is no need to have large MTU. We do support fragmentation. It's not the best for performance, but we do support that. So if you don't care about pushing 10 gig of traffic between locations, east-west, yeah, we do support fragmentation. So we do not require large MTU. We have a simple DR, and this, whatever, before we had it as well in the multi-site, but there were requirements in terms of stretch VLAN and in terms of vSphere HA cross vCenter. Here, there is no requirement at all. We just offer a simple DR. The cons, and here there are a few today on NSX Multi-Site, few important ones. The feature set on network and security is limited. On multi-site is not limited at all. There is just one thing on multi-site, which is again, the service insertion to checkpoint, Fortinet, that's it. Here, there are a lot. Load balancing, VPN, VRF, IDS, IPS, a few. So keep this in mind. There is a large footprint because before you had just an LM, and that's LM cluster. Now you have an LM cluster per location, plus GM cluster somewhere active and a GM standby cluster somewhere. And limited scale. We'll talk about the scale later, but it's not like you can have 1000 ESX in location A and 1000 ESX in location B and 1000 ESX in location C and 1000 ESX in location D. So today we have some scale limits. It's up to where we tested in QA. We'll talk about that in details in the limitation section at the end. Okay, let's go over the questions. Will SRM support IP customization on NSX-T Manager's appliance? No, but I guess your question is for multi-site. Because here there is no need to SRM the LMs. So no, that's why in the multi-site, in the requirements, we say you must have VLAN stretched. Question number 2, is Federation available in VMC? Yes, it is available in VMC. Sorry, in VMC, no, I was talking about VCF, sorry, my bad. In VMC, no, Federation supports on-prem only. And now talking about roadmap, before I never talked about roadmap and I do not plan to talk about roadmap at all in that deck, but just since you asked the question, so yeah, VMC is not supported in Federation between on-prem and VMC. What we plan to do in the future is to have federation between VMC and VMC, so SDDC VMC1, SDDC VMC2, and in a future plus date, federation cross VMC and on-prem. But yeah, today nothing. GM will be in cluster or single instance. GM we'll talk about that. It's a cluster. Really, as you can see, it's 3 VMs on the picture. Recommended cluster of 3 for redundancy. Exactly. If you lose one VM, GM active, you don't want to be forced to move to GM standby. That's why a cluster. Okay, so let's talk about how it works. Okay, so deploy. So I'm on chapter 2 now. The deployment models. And what time is it? I don't have my phone. Yeah, already 20 minutes. Okay. So you have, as we discussed, a GM active and LM in each location. You can deploy a GM cluster active with one VM in each location, and that's okay, as long as your latency between each of those locations, between any of those locations is below 10 milliseconds. And you guarantee there is no congestion between locations, because we have this cluster and they need to be able to talk between themselves fast. And then something cool with this deployment, if you lose one location, let's say location C, then you still have the GM active because you have a quorum. So GM service is there, and the LM1, LMA, LMB are also active. LMC, of course, is dead because you lost LMC. Okay, or the second deployment, that's the most popular. Now the latency is under 150 milliseconds. That's what we test. We want to offer 500, but today it's 150. And you have a cluster of 3 VMs GM active in one location, let's say location A, and GM cluster standby in another location, location B. Technically speaking, you could have the GM active or GM standby in any of the locations where you have a local manager. It could be in a location D, location E, who cares? But customers usually place it where they have also some NSX local, and that's a typical deployment. Something to keep in mind is if I lose location A, then I lost my GM active. So I need to recover the GM service. I need to make the standby active. We'll talk about the DR later, but it's a click. It's not automatic. I need to do a click to make the GM standby active. Waiting for that click, all the services in LMB, LMC are still there, as we talked about, DRS, vMotion, everything is there. You can even go on LM and do quick change if you want to do it quick before you do the magic click on a single click on the standby to make it active. Of course, LMA is dead because I lost the location A. Okay, so the question has been answered. It's the communication flow. So you have a GM active, GM standby, LM in each location. So you create stuff centrally. So on the GM active, you go on the GM active API, UI, click, click, click. You can create, we'll talk about what you can create, but at that point, let's say you create a tier 0, but here you can create a tier 0 stretched. So between Paris, London, New York. So between Paris and London, you could make a tier 0 stretch between Paris, London, New York. But here, let's say I want to make it between Paris and London. Same thing for a tier 1, same thing for the segment. So I do click, 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 or API on the GM active. GM active will synchronize that to the GM standby. So GM standby knows about it. And GM active will push that to the relevant locations, to the relevant LMs. And so here it's LM Paris, LM London, but not LM New York, since nothing in that configuration is relevant to LM New York. Here we go. And now LM London, LM New York, LM London, LM Paris knows about this. There is also another flow. It's between LM and LM. So let's talk about the use case using this flow. It's, let's say I create security. So here, let's say I create a group based on VM names, VM tags, whatever, that is global. So for Paris, London, New York, I show VMs in the same subnet, but that could be VMs on different subnets, who cares? I do click, 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 API, whatever. GM active, synchronize that to the standby. And because it's global, it's pushed to all the LMs. And now each LM will do its job like they do without federation. Each LM will resolve the members locally. So the VM with this tag, it's only VM1 for Paris, VM2 for London, VM3 for New York. But then they also know, and that's new with Federation, each LM will know, oh, that group is global. So let me synchronize, let me tell the other LMs about my VM and my IPs I have locally. So they synchronize, and after 1 second or less, everybody knows about everybody. They know about their local and they know about the remotes. So that's why there is also this LM to LM communication. Yeah, recommended cluster of 3 for redundancy, answer live. And can my can I convert my existing NSX-T manager to LM or GM in future? It's not like an LM becomes a GM. You can have an LM, and then you we'll talk about that actually. Okay. Okay, so now there is also another communication between LM to LM, and it's for this one. So we talked about the security groups. So let's say I create this segment stretched, and okay, each LM will know about its local IP, local MAC of the VM. So LM1 knows about IP1, MAC1, LM2, so on and so forth. And then they will synchronize that. So Paris will tell London about IP1, MAC1, and the others will tell the others. So everybody knows about everybody on the stretch segment. So if VM1 needs to talk to VM2, LM1 told the ESX about MAC2 IP2 belonging to London and MAC3 IP3 belonging to New York. So the ESX knows it has to, on the transport node, I should say, knows they have to cross site. We'll talk about how is the flow, the packet walk, but they know about it. Keep your questions. We'll go in deeper detail on how the cross location is done, packet walk wise. Important point, GM actually, as you can see here on the picture, does not know about VM1 in Paris. I mean, IP1, MAC1 in Paris, MAC2, IP2 in London, and so on and so forth. GM is only the management plane. The realization is on the LM's side, and that's okay. Now, for ease of use, you can go on GM and see that information. Like, let me show you quick. If I go on my GM, it's in my lab. If I go on my GM, come on. So I have a GM Paris that is centrally configuring LM London, LM Paris, and I have a bunch of segments. And if I go on, I'm working from home, so it's a bit slow. If I go on my segments, I can see I have some segments stretched, some segments not stretched, Paris, London, Paris, or London only. And if I click on this, I can see from GM, I'm on GM, I have those VMs, some in Paris, some in London. And this information is actually a UI or API trick. The GM asks the LM and will report that. Okay, but again, it's just management plane and it's not a control plane. Same thing for the groups. Actually, it's a better example. If I go on group and I have some groups that are global, Paris, London, some groups that are Paris only, London only. I told you GM does not know about the members. It's just configuring that and tell GM, hey, that's your group definition, figure out what you have internally and share what you have internally to the others. But if I click on view members, I can see, well, actually, I don't have any here.
Hey, Dimitri.
Let's go to, yeah.
Can I pause you? We're seeing the PowerPoint and we're not seeing, I think you're showing something else, but we're not seeing it. I thought I was
showing my,
your whole desktop. It looks like maybe you just shared, you might have just shared PowerPoint.
Okay. And now do you
there,
see?
Now we see. Now we see.
Okay, too bad. But yeah, you can see from GM, I'm on the GM and GM is managing London and Paris. And here, actually, I don't have much in that lab, but whatever. I can, if I click here, I will see the VMs in London. I will see the VMs in Paris. But actually, you see there is a spin. It's because it's asking the LM, what do you have? So it's just to make my life easier. And it's not like he knows about it. Okay. So yeah, do you see the PowerPoint now? Or you're
Yes,
still
thank
on
you.
the, okay.
We see the PowerPoint now. Thank you.
Yeah, okay, my bad. Thanks. There were a few questions. Okay, LM to LM will sync using which protocol? It's called the asynchronous async channel. But yeah, who cares? It's encrypted. It's on TCP port 1235, I think, top of my head. But yeah, who cares? Okay. SRI, it's encrypted, yeah, as I said. SRI. Anyway, to do this, which one vCenter, even if vSHA is okay. I hope I replied because I don't understand the question. Repo sync service. Yeah, that's the async service for the LM to LM. Okay. Then LM knows about GM. GM knows about LM. LM knows about the other LMs. Life is good. Something you can do optionally is to take the config, the existing config, if it's not greenfield, if you take the existing config of the LM and you want to move it up to GM, so GM knows about it. If you do not do that step, sorry, I'm talking about the registration first. Yeah, my bad. So we did the registration. So GM knows about LM and LM knows about GM. So that's what you did. And how do you do it? You go on GM and you say, give me, let's show it. So now you should see my GM, correct? Hopefully. Yes, no?
Yes, we do.
Yes,
we do see
okay.
GM Paris.
So you go on your GM and you add a new location. Oops. You add a new location and it asks you for the IP or the FQDN, the username password of your LM. And then, okay, LM knows about GM. And then you'll configure RTAP. I won't explain that yet, but you configure RTAP. It's to allow the cross location. So you do those two steps and you're done. There is a second one, which is optional. And this one is for if you register an LM, let's say LM New York. In my lab, I have Paris and London, and that's it. Let's say I want to add New York, and New York has already some old config people did in the past before Federation. I have some switches, routers, security in New York, and I register that LM New York. So after the registration, what do I have? On GM, I have all what is known on GM. I have it with a G icon. So GM knows about the stuff GM created and pushed to Paris and London. And if I have a group that is global, it was pushed to Paris and London. But after I registered London, that group, because it's global, is also pushed to New York. So New York will know about those VMs in Paris and London. But everything that was configured in New York, this tier 0, this tier 1, this segment, those VM, this load balancer, those DFW, those groups, they were known and created and managed by LM New York, and GM still don't know about them because they were created in New York and not on GM itself. So that's fine. It's just GM will not see them when you go on network tier 0. So you have the ability to take the LM New York configuration and move it up to GM. So now GM, after that step, will know about this tier 0 New York, this tier 1 New York, this segment New York, this group New York, and so on and so forth. So you can do that. Just keep in mind, it's a one-time option. So you can onboard New York to GM only once and only once. You cannot do it over and over. So if after the onboarding you create something on LM New York, it will be known by LM New York, but not GM. Then it's the full configuration. You cannot say, take this tier 0, this tier 1, but not that segment. It's everything will move up to GM. It's only policy. You know, we have for the old guys, we have MP and policy. So, you know, if I go on LM, you have, by the way, this location switcher. So that's pretty convenient. I'm still on GM, but I can jump to LM view. And you remember we have policy and manager, policy and MP, API, UI, and only stuff from policy can be, from policy LM can be moved up to GM. And we can onboard only if 100% of the configuration on LM New York is using features known by GM. There is one exception, and I'll talk about it. Like for instance, on LM London, now I'm on LM London. You see, I can do a lot of stuff. I can do tier 0, tier 1 segment, but also VPN, EVPN, load balancing, a bunch of stuff. Security, a bunch of stuff. IDS, IPS, threat detection. Okay. On GM, I can do much less. You can see, oh, I'm disconnected. Log out, sorry. Log in again. On GM, I can do much less. You see, I don't have load balancing, I don't have VPN, I don't have EVPN, security, I have much less. So you can take with the onboarding step, all the LM configuration and move it up to GM if GM understand all the configuration. There is just one exception, is load balancing. It's possible to onboard this, and the LB, if the LB is one arm attached, will remain on the LM configuration, but everything else will move up. If there is anything else I do not understand other than LB, GM do not understand other than LB, then you'll have a message in English that says, hey, you cannot onboard because you're using feature, I don't know, IDS, IPS. And that's okay, but then you cannot have GM for central pane of glass. You'll have GM for the stuff he does configure, and you have to go to LM New York for the stuff created directly and managed directly by LM New York. All segments and edge nodes must be configured with a TZ overlay. We have a default TZ overlay now, so they must be configured using this. And you know, we support for authentication, if you don't want to use admin, but you want to use RBAC with special users like Dimitri, Bob, Paul. On GM, we support only VIDM. On LM, we support VIDM and LDAP, as you can see slowly. Come on. As you can see, VIDM and LDAP. GM supports only VIDM. So all the LM objects to be able to onboard that must be created via VIDM, but not LDAP or admin. And so after the onboarding, also keep in mind, or after the registration, we talked about, you remember, I had before adding LM New York, I had created a tier 0 between Paris and London, tier 1 segment, DFW group, global. So LM New York received the DFW group because it's part of global, but the tier 0, tier 1 were not stretched to New York. And you can expand that tier 0, tier 1 afterwards when you registered LM New York. And it's simply done like I'm on GM Paris, I go on my tier 0. Let's say I add New York. I did not add New York, but let's say I added New York. I can then edit my existing tier 0, which is between Paris and London. And assuming I have a third LM, today I have only 2, but let's say I did a third one. So this will not be grayed out, and I can click on add location, LM New York, and that's it. And it will be stretched. What did I want to say? And then, yeah, if I have onboarded group that is in New York, like actually the picture is not the best one, I should change. Like this one. So you have this group that is only New York, because before it was only New York. So I onboarded it and the span is only New York. I can make it global. For that, there is a script, okay? Because once I create a group, with a specific span, like I create this group LM Paris, or I did onboard LM Paris, and so the span was before only on LM, and now it's GM owned, but the span did not change. You see, I cannot make it global, it's grayed out. So for that, if I want to make it global, I need to delete and create a new one with the same criteria and make it global. So you can do that, click, 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 you can do that API, or we give you a script. I hope I didn't lose you too much. Okay, last thing on the architecture component, and it's 41, perfect. The region. So it's for a specific use case. Let's say you have 4 locations, Paris, London, Boston, Seattle. And you can, by default, you always have a global group with everybody in it. And you have also local regions. So Paris, London, like you can see here, regions. So I did not create this one. You see the locker. So global, and I have my LM Paris, LM London. But I can, if I want, add regions, like add region, and put some LMs in it. Like I could do EMEA, I could do USA, and then once I created those regions, if I want, for security reasons, I could create a group, because I know those applications are stretched, but they are stretched only in the US. So I can create a group, and this group will not be pushed to London, will not be pushed to Paris, will not be pushed to Paris, London, New York, Seattle, whatever I say, Boston, Seattle, but it will be pushed to USA. Okay, so that's the idea behind regions. Good. Now let's go with services. So we talked about in the section 1, we do not support all the services, but what do we support? So let's start with routing, and then we'll talk about services, or networking, I should say. Yeah, I should call that networking instead of routing. So we support tier 0, tier 1 segments, not stretch. You can have a tier 0 stretch to a tier 1 not stretch, or stretched a little bit, or stretch completely as well. I mean, all of the above. Just keep in mind the span of the segment is always equal to the span of the tier 1 or tier 0 it is attached to. So this segment attached to the tier 0 is global, because the tier 0 is global. This segment on this tier 1 is London, New York, because the tier 1 attached to is London, New York. Here we go. On top of tier 0, tier 1 segment, we support NAT, gateway firewall, IPv6, DHCP, DNS. A quick note on DHCP. DHCP, we support static binding and not pool. So you have to, if you use DHCP on GM, configure DHCP on GM, it has to be static binding. Now, because now we have the concept of stretch tier 0, tier 1. So what does it mean? And we have 2 options when you configure those. You can make that a tier 0 stretched primary, secondary, which means 100% of the north-south will go via the primary location. but the east-west is everything, and we have DR. So a VM in location 2 that needs to talk to a VM in another subnet in location 3 will go from location 2 to location 3 and not 2, 1, 3. So it's fully distributed. Or we have all primaries. And in that case, all the VMs in location 1 will exit via location 1, 2, 2, 3, 3. Okay. I have a question there. Tier 0 active standby, not stretch. Can a tier 0 be connected to a tier 0? Yes, you can. That's fine. They don't know it's a tier 0 to a tier 0, but yeah, that's fine. And does the DHCP service include DHCP relay? Yes, I forgot to mention that. Good point. Okay, so now we talked about primary, secondary. Now within a location, you can be active standby, which means only one edge node in this location will do the job, or multiple edge nodes will do the job. Of course, if you do active, then you cannot do stateful services like NAT or firewall. If you do active standby, you can. So let's combine those. So you can have a tier 0. I'm showing 2 locations, but of course it could be more. 3, 4 locations. I can be active standby within a location, primary, secondary. So east-west distributed, but north-south will go only via one location. And a VM in location 2 will go to its secondary active, so edge node 3. Then edge node 3 will send it to edge node 2, the primary active, and out. Same way for the incoming traffic. Or I could be active within a location and primary, secondary. In that case, edge node 3, edge node 4 will receive all the traffic, that they will send it in ECMP to edge node 1 and 2, and it will go out. Or I can be active, primary. And in that case, north-south, oh, this arrow is a little bit off. North-south will go locally. Just keep in mind, you have asymmetric routing when you do the active, primary. You have local egress, but not local ingress. Okay. Now for the tier 1, you can do a tier 1 stretched DR only. So no SR, no services. And in that case, it will go straight to the tier 0. And that tier 0 is maybe active, standby, primary, secondary, primary, whatever. But it will go straight from ESX to the edge node where you have the tier 0, edge nodes where you have the tier 0 locally. Or you can have a tier 1 with services, so with an SR, primary, active standby, primary, secondary, which means all the VMs will go via edge node 3, edge node 2, or directly edge node 2, and to the tier 0. And that tier 0 is again whatever. So I hope you had a good mug of coffee before, and I didn't lose you already. So let's do the packet walk. So let's say I have a stretch segment orange, stretch segment yellow, okay, connected to a tier 0 or tier 1, whatever. And let's say VM1 talks to VM2. And yeah, something I forgot to mention. On the left, it's the logical view. So the VMs don't know anything about NSX Federation, don't know anything about NSX period. They believe VM1 and VM2 are in the same subnet, 2020, 2011, talking to 2012. But with this configuration, on the right, logical configuration, on the right side, I have the physical view. And for each stretch segment, NSX will choose a couple of edge nodes to be the L2 cross communication active and standby. So in my example, let's say edge node 1, edge node 2 are the active standby for orange. Edge node 3, edge node 4 are the active standby for orange. But it will be other edge nodes or the same edge node, but in a reverse order for yellow and so on and so forth. In the design guide, you can see all the details on how it is selected. And logical view, the packet walk. I mean, VM1 doesn't know anything about NSX, as we discussed, so it will go straight to VM2. Now, in real life, what is in physical view? What is a packet walk? ESX1 knows from LM1. ESX1 knows from LM1. VM2 is in London. VM IP2, MAC2 is in London. And ESX1 knows the to go there, it's via edge node 1, which is the orange cross-location active edge node for L2 cross-location. So ESX1 will send it on TAP on Geneve to edge node 1. Edge node 1 knows it's behind edge node 3, which is the active, because LM to LM, they talk to each other, and LM London told LM Paris, edge node 3 is the one for orange. So Geneve protocol again to edge node 3 and edge node 3 to ESX2. In terms of VNI, you don't have to know that, but anyway, yeah, they can be different. Who cares? Each LM is in charge of selecting those VNI. So 5001, 6001, 6003 for London. Each LM selected that. But for this one, the GM told LM Paris and LM London, hey, use 5002 for this one. And if it could be 5001, because GM doesn't know what LM selected for the TAP, but that's fine. There is no conflict because those are different purposes. This one is for the TAP, this one is for the RTAP, remote TAP. So yeah, you don't have to remember that. It's done for you. And yeah, that's how it works. Let's go through questions. Is it single site ingress, egress, or can we'll talk about that. Here we talked about the east-west L2. We'll talk about the routing in a second. But yeah, quickly, actually, we talked already about that. If you go with this mode, primary, secondary, active, standby, primary, secondary, active, active, then it's a single site for egress, ingress. And for this one, active, active, primary, primary, it's multiple sites for egress. And then for the ingress, it depends on how you advertise the subnet. So here you have a subnet segment, let's say 20.20.20.0/24. You can advertise it with the same cost from Paris and London, and then the ingress will come a little bit from here, a little bit from there, but you don't really have control. Maybe some people will come via Paris for a VM that is physically in London, or vice versa. So you don't have control, but you can do it in an active-active for the ingress, or you can advertise 2020/0/24 better from Paris, and all the ingress will come there. Okay. And then in active-active, can we control egress traffic based on source? No. Here we go. Okay, so we talked about this. Now let's do a packet walk L3. I picked up a tier 1 DR on that slide stretch and a tier 0 active-active primary secondary. But as you know, we can do many combinations. It could be a tier 1 with services with the same tier 0, or tier 0 active standby, primary secondary, or active-active, all primaries. All the examples are in the design guide. That's why the design guide is 200 pages. And you have a packet walk for all the different combinations. So feel free to look at it if you have another use case. And the packet walk are for east-west and north-south. I'm just here showing you one again, and then if you have another one in mind in terms of logical topology, look at that. So let's go with this one. So again, left logical view, right physical view. And let's say VM1 wants to talk to internet. So oh, and by the way, on the left, I want to use the left for internet. And I have a subnet backup or storage that is physically in London. So I want everybody to exit for internet via Paris but for storage, I want them to exit via London for the subnet 30/30/30. Okay, so now my VM1 wants to go to internet. So logical view, VM1 goes to the tier 1 DR. Physical view, VM1 goes to the tier 1 DR. Tier 1 DR goes to tier 0, active, so ECMP. Tier 1 DR goes to tier 0 DR, goes to ECMP, edge node 1, edge node 2, and then goes out, and then goes out. Now, VM2 wants to go to internet, and VM2 is physically in London. VM2 to tier 1 DR, VM2 to tier 1 DR, tier 1 DR to tier 0, the tier 0 local, so tier 0 DR, edge node 3, edge node 4, ECMP, but this slice of the tier 0 in London is secondary. So then to edge node 1, edge node 2 to Paris, ECMP, and out. And here you can see it's encapsulated Geneve, and not encapsulated. Now, VM1 wants to go to 30 network for storage, for backup, whatever. VM1 tier 1 DR, VM1 tier 1 DR, tier 1 DR, tier 0 local, slice local, tier 0 DR ECMP, edge node 1, edge node 2. Then, because I did configure or I learned via BGP, the subnet 30 is via London. This tier 0 knows the subnet 30 is via London. So edge node 1, edge node 2 knows, they know it has to go to London. So Geneve to edge node 3, edge node 4 ECMP, outside. And VM2 to subnet 30, tier 1, tier 0, local tier 0. And this tier 0, again, it's in the logical view, it's a single tier 0. This one knows 30 is via London. So edge node 3, edge node 4, they know the default gateway is via edge node 1, edge node 2, but they know edge node 3, edge node 4, it's the subnet 30 is local via the top of the rack London, static route or BGP. Out. Here we go. Any question there? But in this design, this is not recommended to set up IPsec session between tier 0 and different locations. I have a single tier 0 here, so I don't get your question. It's not I have a tier 0 Paris, a tier 0 London. I have a single tier 0 Paris, London. And yeah, so yeah, not sure I get the question. You can ping me later to clarify your question. Now let's go east-west. And again, I picked up this, but I could pick up any other thing, different tier 1, maybe DR, maybe not DR. And let's say VM1 wants to talk to VM4. So VM1 to tier 1, VM1 to tier 1. Tier 1 will do its routing. So tier 1 will do its routing. So now the routing is done and I need to go to VM4 on L2. So how do I go from here to VM4 on L2? It goes to the edge node in charge of doing the L2 stretching. So here for yellow, it's edge node 2, Geneve for this one, which is in charge of the L2 stretch, and VM4. Now let's say I have this, two different tier 1s. So VM3 goes to tier 1, yellow. VM3 goes to tier 1, yellow. It's a tier 1 DR only. Then it goes to tier 0, DR. So I stay on the ESX. Then it goes to tier 1 DR. I stay on the ESX because it's all DR. There is no SR involved. In my configuration, I did not configure a tier 1 with an SR with firewall or NAT. So all inside the ESX. And then the ES routing is done and I need to go to VM2, which is on the other side. So ESX knows the edge node for orange, for L2 orange stretch. It's this one and it goes out. Okay. Last one, this one just to show, but it's all done internally. You don't have to understand fully this. Okay, VM3, and now I have a service tier 1 with the service. So, oops, sorry. So VM3 goes to tier 1, VM3 goes to tier 1 DR, tier 1 SR. And this tier 1, by the way, is primary in Paris, and this tier 1 is also primary in Paris in my configuration. Of course, I could configure something else. So tier 1 DR, tier 1 SR, then goes to tier 0, then tier 0 DR, then goes to tier 1 SR. And for the fun of it, I made the active of the tier 1 orange on this edge node. It could be on the same edge node, but just for the fun of it, I made it here. So edge node 1 will Geneve to edge node 2, then it goes to DR, and then it needs to go to VM2. So which one is in charge of the L2 cross location? In my example, it's here. So I go here, here, here. Here we go. Again, it just works. You don't have to understand all of that. But yeah, the goal was to give you a deep understanding on how it works, if you want to. And the last one, and then I'll stop there. I'll go fast. Tier 1 DR. I mean, yeah, actually, I'm late. Okay. That's a screenshot of the design guide that explains, you know, this to know which one will be the L2 stretch active standby for cross communication. How can you know which edge node will be selected automatically by the local LM for that job, for this, for this? It depends on that segment, if it's connected to a tier 1 DR, tier 1 SR, or tier 0. So yeah, read this. And in CLI, you can also see that on the edge node itself to know if it's the one in charge of a specific segment, which one is in charge of doing the active and standby, and on the other side, the remote on the opposite location, which one is in charge of being the active or the standby. Okay, routing. The other sections are faster, easier. Routing, I still need some of your brain cells. So you can do a tier 0, we talked about that. Stretch, not stretch, tier 1, stretch, not stretched. Now, what do I have here? Yeah, okay. And I can create on that single tier 0, I can create BGP or static routing with their specific slice top of the rack. But again, it's a single tier 0. It's not 3 tier 0s here. It's a single tier 0, Paris, London, New York. You can configure BGP static route for each slice. And this you do not configure. Everything that is learned on a specific slice is redistributed to the other slices. And how do we do that? It's internally, we configure, you do not see that, but internally we configure IBGP between each slice. So everything Paris will learn will be distributed to London and New York. So how is configured IBGP depends on if it's active, standby, active, active, primary, secondary, or all active. So you can read that, or you can just simply look at this picture. So again, in the design guide, I talk about the 3 tier 0 support you can configure. So here I'm showing one, but I'm showing the tier 0 active, active, primary, secondary. If you configure something else, look at the picture in the design guide. But how do you read this? So at that point of time, I just configure a tier 0. So I advertise nothing because I have nothing below the tier 0. Okay, good. Now your top of the rack is most likely configured via BGP to advertise a default gateway. And let's say some other subnet in Paris. So what happens when I configure BGP on my tier 0 slice Paris? The tier 0 slice Paris, edge node 1, edge node 2, we learn default gateway via the top of the rack Paris, and 31 via the top of the rack Paris. And because we have the IBGP between each slice, Edge node 3, edge node 4 will learn default gateways via edge node 1, edge node 2, and 5, 6 via edge node 1, edge node 2. Same thing for subnet 31. Now, when I configure BGP on my slice London, actually, because London is secondary, the top of the rack London will advertise default gateway, but London will not learn it because it is secondary. So nothing changed. But for 32, which is not the default gateway, London will learn 32 is via London and will tell Paris edge node 1 and 2 and 5 and 6 about 32 subnets via London, via edge node 1, edge node 4, edge node 3, edge node 4. Okay, same stuff in New York, same story. Then I plug, let's say, a tier 1 segment. So this segment is advertised via the tier 0, slice Paris, London, New York. So the world or the top of the rack Paris will learn about it. London will learn about it. New York will learn about it. By default, we configure it with the same cost preference. So, but you want people to come via Paris because that's your primary. So you have to manually configure some extra cost for the tier 0 slice London and the tier 0 slice New York. So that subnet is advertised from Paris at a better cost than London and New York. And then let's say you plug a tier 1 with a subnet, same story. It's advertised via Paris, London, and New York, but a better cost for Paris and worst London and worst plus New York. Now let's say, so same story. Let's say now I don't plug a tier 1 DR, but I plug a tier 1 only in Paris with SRDR. So 10.4.1 will be advertised via Paris, but because it's only in Paris, this tier 1, it's not advertised in London, not advertised in New York. Let's say 10.02. So this one is advertised from Paris because again, it's your primary location. So people for 10.4.2, they have to come via Paris. It's actually also advertised from London, but at a worse cost, and not in New York because 10.4.2 does not exist in New York. And 10.4.3, same story. 10.4.3 here, Paris, not London, but New York at a worse cost. Let's say you create a tier 1 with services that is primary in Paris. It's advertised from Paris only. And let's say it is another tier 1 that is primary in London. It's advertised. Oh, I have a typo. It's also advertised from Paris, of course. My bad. Design guide is good. The PDF design guide is good. And advertised from London, but better cost in Paris. And yeah, I forgot to mention it here. Okay. Whew. That's it. So I'll let you go slow on this one by yourself and digest that. Okay, now security. We have another 20 minutes. Let's speed up. Yeah, I knew I wouldn't have time to do everything. Security goes faster. So I can create groups, global, local, regional, local, and I can create, yeah, click or API, security rules between any kind of to any kind. Okay, and I can use dynamic for people who do not know NSXV, who do know NSXV. In NSXV cross vCenter, you had to use IP subnet, but not dynamic membership. NSX-T you can, so that's pretty cool. Okay. And I'll go super fast and you'll go to the design guide to go through all those details. But yeah, you can create groups like this, let's say. And so when you create groups like this, LM1 will know about group 1, 1, 2, 3, 4, 5, 6, LM2 as well, LM3 as well. But group 2, LM3 will not know about it because it's the span of the group is not with New York. So all that makes sense. Then you can create rules. and inside section. And you can create sections that are global, sections that are regional, sections that are local. And then you can create groups. In any section type, you can use any group type. There is just one exception. If you have a span of a section which is local, let's say Paris, location 1, you cannot have a from and a to with groups that do not belong to Paris, location 1. That does not make sense because your span is Paris and you take a group London, New York. So there is no VM in Paris with those groups, so there is no point of doing it. So we prevent you to configure something stupid, and you'll get an error if you try to configure that. However, if I take this region Paris, I can create a rule, sorry, that is from a group Paris to a group London. That's okay. It's allowed and it makes sense because yeah, maybe the destination is in London, but your group's source are in Paris. So yeah, you may want to create a group 4 to group 5 rule and you apply that to only Paris. And in that case, rule 33, then it will be pushed to the VM in Paris because your span is in Paris. Now, why do I have some warning here? I'll just get an example. Let's use rule 23, but it could be some other rules, but for time, I'll take just one and you'll read the others ones. So this one is correct, the rule 23, but why do I say it's improper or what do I say? Or not optimal? Let's look at this one. So I have span region 1. So Paris, London. That's my span of the section. And then I have a rule group 2. So from group 2, so from this group to group 1. So from this group to group 1, to that group, I allow IMAP and I push that to all the VMs, so everything that are in region 1. I push from group 2 to group 1, IMAP drop. So why do I say improper? Because this rule will be applied to VM 7, 8, 9, 10, 1, 2, 3, 4, but also 11, 12, 15, 16, 13, 15, 14, and they don't care at all about that rule. So that's a little bit stupid. And yeah, it's not optimal. Those VMs, Linux will receive that rule and for no reason. So it's loading those ESX, it's loading those ESX hosting those VMs for no reason. So always apply to the source and the destination. And also in that specific case, group 2 talking to group 1, VM5, VM6 will not receive it because it's pushed to all the VMs in this region, and VM5, VM6 are not in this region. So the traffic will be allowed when VM7 wants to talk to VM5 on this DFW rule on VM7. But here VM5 will VM5 accept that traffic? I don't know, it depends on what other rule you have pushed to VM5, but hopefully you have a rule that accepts this. It's not guaranteed. Because again, this rule 23 will not be pushed to VM5, VM6. To fix that, you would need to put this rule 23 on a section that is global. And then GM will push it to LM and will push it to VM5, VM6. Okay, so that's the idea. And I have zillions of other examples here. A few things to keep in mind on security. VM tags. So you can tag VM1, you can tag VM2, you can tag VM3 with the tag 1, and you can create a group, let's say global, that has dynamic membership, all the VM with the tag 1. And we talked about this. Each LM will do its local resolution and then synchronize with the other ones. So that works. If there is a vMotion outside of NSX, a vMotion or whatever, that is moving VM1 from Paris to London, the vCenter will keep the tag. So that's good. I mean, the tags are NSX. What I mean is when vCenter will move the VM1 from Paris to London, then the vCenter will do the move. The ESX in London will receive the VM. The ESX in London will receive the VM and knows that VM had a tag NSX. And so the ESX in London will tell the NSX in London about that new VM and about that tag on that new VM. So NSX Manager London will learn the tag and will populate the tag in its configuration. So that works fine. Another point to keep in mind, on GM, I can create, I'll go there. On GM, I can create, oh shit, I've been disconnected. Yes, no. I can create sections and rules in infrastructure environment application. If I go on LM, I can create also on emergency and Ethernet. So if I'm the big boss of GM and you are the big boss of LM London, and you want to do something that is done before the GM rules, you can do any GM rule. You can create a section here and do your stuff as the LM admin, and those sections will be pushed before any GM rule. Otherwise, if I go here under application, I'm the LM London boss, not the GM boss here. I can create a policy section, but this policy section will always be below the GM received section for a specific category. I cannot put it above. If I want to put it above, then I do it under emergency. Okay, that's what this says. Okay, best practice. Oh, sorry, there was a question. Limit 30 tags per VM is still, yeah, that's the tags are done on LM. Yeah, revert. You see on, oops, I'm on LM London. I go to inventory, I go to VM, and that's on LM where I put the tags. Do I have some VM with tags or just one? But yeah, that's on LM. I put the tags. On GM, I do not have, actually, I do not see the VMs. I can create groups. I can create groups based on VM tags, but again, the VM tags are created on each LM. And why were there a question mark always on the button role with source any? I don't know, you'll show me, read the use case. I explained that, no time to go through all of them, but there is always a reason, and the reason is most likely because you want it pushed to all the VM that applies, and the rule, the way I did it, it was not pushed to all the VMs, or it was pushed to too many VMs. Ping me when you read the deck or the design guide where this is detailed, and one of those don't make sense. Okay, best practice security. Actually, here we go. I'll show you an example. It's maybe not the one you had in mind, but oh, this we talked about it, exactly the one I said. So yes, this is improper because you remember, this is pushed to all the VMs in Paris, London, where actually I want that to be pushed only to the VMs belonging to group 2 and not the others. So that's pushing it to too many VMs. And also it was not pushing it to the VMs in New York that belong to group 1. So the optimal configuration is region global and same rule, and apply to group 1, group 2 only, and not all the VMs of the world, because yeah, you have this. Okay, data plane best practice. So we talked about it. There is TAP for within a location, RTAP cross location, and VLAN for the uplink tier 0. So that's the type of traffic you have, or NL2 bridging. So that's the type of traffic you have in the data plane. For best performance, okay, on the edge node, you could dedicate a specific interface for TAP, another one for RTAP, another one for VLAN, another one for VLAN bridge. But that would be many, many interfaces, especially if you want 2 for each for high availability. So what do we recommend? Let's say it's an edge node VM with within an ESX with 4 PNICs. I say 2 PNICs here, where I show 4 PNICs, so there is a mismatch. But anyway, the design guide is good. I did that too late. But anyway, so yeah, what we do recommend is, in that case, you do 2 TAP, 2 PNIC for the TAP. I mean, you do an NVDS, sorry. You do an NVDS for your TAP traffic and your RTAP traffic. Today, TAP, we support multi-taps for an edge, for an edge node. And so, so yeah, you'll have 2 IPs. For RTAP, we support only 1. In the future, we plan to support 2, but today it's only 1. And the day will support 2, then automatically it will add another one, and that's good. But yeah, that's what we recommend. And another one for the VLAN bridging. And your ESX is configured like this. I'm running out of time. If you have questions on this, if it does not make sense once you read the explanation in the design guide, feel free to reach to me, but it should make sense. It's very close to, it's actually the same topology we recommend without federation. That's how you configure your edge node and your ESX without federation for an ESX with 4 PNICs. The only addition is the RTAP will be on this NVDS. And oh, sorry, no, my bad, I'm stupid. It's really 2 PNIC. Yeah, the ESX has 2 PNIC. I'm stupid. That's the VNIC of the edge node. So the ESX has 2 PNIC. You configure your edge node like this with 2 NVDS, and your ESX like this with those port groups. And if you have 4 PNICs on your ESX, you configure the port groups on your ESX like this, which is different, as you can see, and the edge node inside like that. Okay. Now, if it's bare metal, yeah, we're running out of time, but yeah, that's the idea on how you would configure it with 2 PNIC and like this with 4 PNICs. Okay, disaster recovery. I really want time there. 10 minutes left, so I really want time there. You had some questions. Let's go quick. Yeah, if you have any in source or destination, you need to push it to DFW. No, no, I disagree. If, for instance, if your rule is from any, you can talk HTTPS to the web, to the group with the VM tag DMZ, I make it up. I have a group with the VM tag DMZ. That's all the VMs inside with the tag DMZ, because they have all the portals, HTTPS portal for my outside communication to the world, so clients can access my different services. And my rule again is from any to my web, my group DMZ HTTPS. Where do I need to push that? Only to my group, my VMs DMZ, not all the VMs everywhere. So it's not because you have an any, they have to be pushed to all the VMs. Can we use when we have vSphere 7 VDS instead of NVDS? Yeah, definitely. Yeah. Okay. So Dia, I want to spend few times there, a lot, yeah, sometime here. So you can do tier 0 different ways. You can do tier 1 different ways. So let's pick one here. To again, the design guide covers the same kind of topology and flows for all the possible logical topologies you can make. But let's go here with a voiceover on that one specific. So let's say I have a tier 0 active, primary, primary in Paris, and a tier 1 that is DR only. So when everything works fine, 100% of the traffic will be like this, north-south via Paris, and east-west fully distributed. Okay. Now, if I lose New York, no big deal, everything still works. Of course, not for New York, but north-south works and east-west works between London and Paris. If I lose Paris, which is, again, my primary location of my tier 0. So the subnet here was advertised from Paris and London and New York, but better from Paris. Now I lost Paris. So it's advertised from London and New York, but now the new best cost is London. So 100% of the traffic will come from London. Then it will go to VM3, VM4, VM5, VM6. Of course, not VM1, VM2, because Paris is dead. The outgoing traffic, VM4 will exit locally because the tier 0 slice London knows the tier 0 primary is dead. So it will receive the default gateway from the top of the rack London and accept it, and will not take anymore the default gateway from Paris because it knows Paris is dead, so it will take the default gateway from local. VM5, VM6, the outgoing, the egress, will go to their tier 0 local, and then that tier 0 local is secondary. It had before a default gateway via the tier 0 primary, but now it's dead. So it will take the default gateway via its local. So now New York will exit via New York. London will exit via London, but 100% of the traffic will come from London. So it will work, but if you have any physical firewall on the physical fabric, nothing to do with NSX, then you have asymmetric routing and that will be blocked. Okay, but if you don't have any physical firewall on the physical fabric, then there is asymmetric routing and it still works. Okay, and in the case of split brain, 100% of the traffic will come from Paris because that's advertised from Paris at the better cost. So it will come from Paris, will go to VM1, VM2, but it will not be able to go to VM3, 4, 5, 6, because in my use case, I say, hey, the communication between Paris, London, and Paris, New York is dead. So people can talk to VM1, VM2, and can VM3, VM4 send traffic, initiate traffic to outside? Yes, it will initiate traffic to outside, but it will come back via Paris, so you're dead. And east-west, east-west is dead from VM1, 2 to 3, 4, 5, 6, but 3, 4 can talk to 5, 6. Okay, again, all the others are explained there in the design guide if you do other tier 0, tier 1. 3 minutes left. Okay, quick, how to learn more. You go here on NSX community, there are demos. So please watch them. They are pretty cool, where I show you how to configure on your GM central configuration for your network services, central configuration for your security services. I show you in this demo number 1, data plane. I mean, the real traffic, I show you how it works. And in this demo, I have Paris and London with latency between the two. So you can see that, it's pretty cool. And I show you a DR in the demo number 2. In the demo number 2, I show you what happens when I lose Paris. And depending on the way you configure tier 0, tier 1, the traffic is automatically recovered in 4 seconds. No human touch, but I show you on other topologies, different tier 0, different tier 1 topologies. then it is not recovered automatically, and I need to do a couple of click to recover the traffic. So I show you all this. Please watch this if you want to learn more. There is also a vPod to do it yourself. So you can have my lab for you and you play with it. You have to deploy this one. It's under all the worldwide VMware VCD vPods. You deploy this one, and there is a PPT that explains what is pre-configured for you, which is everything, which is actually this. You have a tier 0 stretch, a tier 1 stretch, a few segments, a few VMs with a 3-tier app application running some components in Paris, some components in London. You can try the vMotion, you can try the DR use case, you can try the security. All the PPT explains you how to show that for yourself or to a customer. It's all pre-configured, but nothing prevents you to change configuration and play on your own. Okay, so that's the one you need to deploy, and you have this all pre-configured, ready to go. Then you have this giant 200+ pages that goes much deeper than what we've done yet. Okay, and we are at the end of time. So requirement limitations, I won't have time to go over it, but it's in the design guide and on that deck, but it's also in the design guide. They all make sense actually. And I talked about that before, like the services available on network and security and the services not available on network and security for Federation. So you have those listed here. Orchestration, that's a good point. We support Federation is another new set of API. So if you want to orchestrate that via API with some tools, they need to talk that new set of GM API. What do we have today? Terraform and Power CLI. If you use VRA, you'll have to wait for 8.4 for some of it and 8.5, VRA 8.5 for some of it. To be able to orchestrate, to consume and create stuff on GM from VRA. Terraform Power CLI or directly straight to the API you can do today. Scale, go to config max. Oh, actually, I need to update this. 3.1.1, it's still 4 locations, but it's now 620, top of my head, ESX. Oh, it's written actually. It's 3.1, my bad. Oh, I should say 3.1.1 because it's already there. Oops, let me fix that. And it's already there. So today it's 624. Migration, if you want to go from single location to an NSX Federation, in the design guide, I explain you the steps, but we talked about that before. And if you want to go from multi-site to Federation, that's a pain. It's possible, but you see all those steps, it's a pain. So make your decision to go to multi-site or Federation at the beginning and then stick to it. Otherwise, it's possible, but complex. Troubleshooting, there is a nice page on Confluence to do deep troubleshooting. Here we go. That was I did accelerate at the end, but yeah. Is there a limit for stretch tier 0, tier 1? Yes, there is on config max. It's a lot, but yes, there is. The main limitation is really the number of ESX you can have. Yeah, and I don't expect with 624 ESX you to create thousands and 20,000 tier 1. So you'll be fine definitely there. Okay, I did answer to Q&A on the fly, so I hope you appreciated that, and I hope that was useful for you. Again, plenty of stuff if you want to learn more. Especially, I do recommend you to not read that. I mean, yes, read that, but it's a big giant book. Only if you have insomnia troubles. But yeah, play with the product and you can use this vPod. It's all configured for you. And that's the best way to learn. And you have also those 2 demos. It's also a good way to learn. That's it. Again, thanks for your time. I'm 3 minutes late, not too bad for French. or 4 minutes late now. Not too bad still for French. I hope you appreciate it, and hope to talk to you soon, and even better, see you soon at some point with this end of COVID coming soon.
That's
Thanks,
great.
guys.
Thanks, Dimitri. So that brings us to the end of today's content. Again, thank you so much. That was really useful. As we mentioned at the beginning, this presentation was recorded, and your TAM will make that available to you, and as well looking at the presentation so that we can share all the links as well.
Yeah, and if you're in a hurry, all the links, you go to Vault and you go to the multi-site page. I'm going there. I'm in my laptop. I'm from home.
Dimitri, these are customers here. Yeah, on the call.
Oh, for customers, that's on NSX Community. You Google NSX Community, you'll find all of them, except the vPod, obviously, because vPod, you have to be internal. But everything is on NSX Community. You just Google NSX Community. I even don't know the URL. Google is super smart. Here we go. And you go on NSX Documents. Come on. And the Federation Design Guide, 200 pages, it's here. Federation, look for Federation. The Federation deck, it does not go as deep as this one, but it's a very good deck for customers. For the one going super deep, I mean, there is a design guide, so that's here, which is even better than the deck I used today. The demos are here. So yeah, you have everything except the link to the vPod. And the link to the vPod, you go to NSX, you go to tech resources, you go to cloud, you go to cloud page, and you have again all those links going to NSX Community and the vPod. Here we go.
That's great. Thanks, Dimitri. The next session will be on the 15th of April, and that will be on digital transformation. We look forward to seeing you all then. Thank you very much, and have a good afternoon. Thank you.
Okay, you too. Good morning, good afternoon, good evening. Bye, guys.
Bye.